Maybe we start. Yeah, Derek.
Yeah, I think so. I just started the recording, so just so I remember when I'm uploading, this is April 24th, and we got a packed agenda. So, Dawn, either you or me can walk through the.
Please, you can
sequence.
walk. Yes, please.
Yeah, sure. So I think first on the agenda today was Mernal, Vikas, and Jan wanting to talk about a CAP that they've been offering for user namespace support. Can the group of you walk us through what you've done thus far and what you'd like to tackle in this release?
Sure. So do you guys see the link, or should I share my screen or something?
Sharing your screen's fine if you can, Mernal.
Okay.
Got a unicorn.
Okay. Do you see my screen?
Yes.
Okay. So I'll try to give a brief overview of what this KEP talks about. So the main motivation for the first phase is node level user namespace support. What it means is, so just before I go into that, do we need an overview of what user namespaces mean and how they work, or I can assume that?
I think if you just want to do a 3-sentence summary, that's fine, Mernal.
Okay, sure. So basically, user namespace is another namespace in the kernel that allows you to map like host IDs to different IDs inside the container. So basically, you can have the 0 in your container to be mapped to a non-zero on the host. So this is powerful because it allows you to do root-like operations inside the container while being non-root outside. So in case if your container process is able to escape the container somehow, the node is protected from the container. And the way this works is like there's a mapping, and the mapping specifies 3 things: the beginning host UID, the beginning container ID, and the size of the mapping. So typically we want the container ID mapping to begin at 0, and then we pick a reasonable size like 65K or 30K or something, and pick a starting host UID. So for phase 1, the idea is that the node will have a single user namespace mapping. This is similar to how like Docker has support for user namespaces. You give a user namespace for the daemon, and all the containers use that user namespace. So that's phase 1. And to enable that, we are proposing one flag, a feature gate, which is node user namespace equal to true. When that is set, we propose that kubelet uses a new CRI API called runtime config info to get the user namespace mapping from the container runtime. So if you want to take a brief look at the changes, here they are. We copied the settings from the OCI runtime spec, so it's consistent and it looks similar everywhere. So you have a Linux ID mapping with the container ID, host ID, and the size of the mapping. And then you have the new call for the runtime config info, which returns the user namespace config. Now, user namespace config has an array of UID mappings and GID mappings. And typically, UID mappings and GID mappings will be the same, but we should just expose it for future flexibility if there are ever use cases where we want them to be different. And under the hood, we can keep them the same for now. And one more thing that is needed is the ability to disable the user namespace. Like I think sometime in the past, we had added a feature gate to default host user namespace. And that could be done on the basis of like selecting any other namespace as host. So typically when you want your PID or IPC or net to be host, you'll also want your user namespace to be host. Otherwise, you'll run into like permission denied that don't make sense. So whenever we see that one of these is set to host, we automatically set user namespace to host. And then there are non-namespace capability like mknode, systime, sysmodule, or if the pod is trying to use a host path volume. So basically, when you set this flag to true, then on the basis of these conditions, the host user namespace is selected. And for that change, we need to expose that in the CRI to pass it down to the runtime. So here's another value in the namespace options for user. And for the runtime support, we need to add another line for containerd, but basically Docker already has this flag. Cryo has a work in progress, and Akiro mentioned that containerd also supports user namespace mapping. So there's a comment, we'll add it to the KEP for containerd. And the plan is, there'll be two phases. The alpha is when we enable the node user namespace gate and add the CRI API, and the kubelet will handle volume source tuning once it gets back the user namespace info back from the runtime. And for Docker Shim, we've given some implementation details on how we can implement the runtime config info. And for the newer daemons, I think like Cryo and containerd, it should be easier to just return the default user namespace mapping. So Docker info doesn't return the mapping today. It tells you that user namespace is enabled in the daemon. But we can take a look at etc subuid file in which it has a doc remap user, and we can get the mapping from that if we see the Docker info is showing the daemon is configured with user namespaces. Beyond that, like for phase 2, we also plan to add a tunable, so the user can request host user namespace to be true. Now, why do we need it? Like defaulting will work for most of the cases, but in some cases it isn't clear whether we want host user namespace to be true or not. Like if you say, I want a privileged pod, you could mean that I want all the capabilities, but it's not clear whether you want the user namespace to be turned on or off. So that's why it will be useful to make it explicit for those cases. And what else? Yeah, so like this KEP is totally talking about the alpha phase. So the details of the beta support will be covered in a new KEP. And then even later on, we'll talk about like pod level user namespaces after all this is done. That is way out in the future because we still need features in the kernel and other changes to make it more performant and useful. Because the kernel doesn't have the file system changes where you can share the same layers between the two pods without choning them. And if you chone, you end up using too much disk space. So we can go into that later on. So that's an overview of the proposal. Vikas, is there anything I forgot to mention?
No, I think you covered almost everything.
Okay. Are there any questions, concerns?
My biggest concern is just the security. And for this one, because by looking at last couple years, the Linux kernel vulnerability, a lot of actually it is related to the user namespace.
Right. Mm-hmm.
Do we have to put any thoughts on that one? How we prevent those kind of things, like the certain of the capability, even you are inside of your own namespace and inside that container, and we don't grant you those capabilities. Did we ever think about those security?
So, like the way like capabilities work is the capabilities are tied to a user namespace. So, I mean, theoretically, with user namespaces, we can actually grant more capabilities, assuming that the kernel doesn't have bugs. And like as far as the kernel bugs, I think, I mean, this is a feature gate, and more people will try out, more vulnerabilities they'll find out, and the kernel will become more secure over time. I don't think like not trying to use it at all is a good way to mature the feature. Like if we add this feature, more people can use it and find more vulnerabilities, and then then other people will be confident in enabling the feature.
I think a lot of those kernel vulnerabilities are exploitable simply if the kernel has user namespace support enabled. So even if you're not using or running in a user namespace, simply having access to that API exposes you. So I don't really think this is increasing the attack surface very much.
How does this relate to SE Linux labels? Would you still apply like a separate SE Linux label per pod?
Yeah. So this is like, the container security is like an onion. We're just adding another layer.
Yeah.
So in top of all the things we have today, we're also enabling user namespaces. And we are hoping that it gives us more security. And over time, we've seen fewer bugs in that area. So yeah, SE Linux will still be there. See, all the other features will still be there. What we aim to accomplish with this is that you should be able to set this flag to true and get the additional security of user namespaces and also additional features, because you can run more pods as root and do more things inside a pod which you couldn't earlier.
Okay.
And one more thing I would like to mention is like we are proposing 2 flags here, but I think most likely we would also want to like fold these 2 flags into a single flag, because I don't see a lot of cases where you would enable node user namespaces but not enable host user namespace defaulting, because you would always have some pods which will run in the host namespace or something. So depending on, I'm looking for feedback here. And
yeah, I think on that point in particular, Manal, I tend to agree, and I think given the way, like the issue had always been like, do you run this at mission controller to actually get the defaulting logic to take place? And I think the API machinery is moving towards a path where it's harder to disable these things. It's more like you have a fixed ordering, it's there, it's on by default or off. So I would prefer in fullness of time that we collapse it to one feature gate, but and it gets wrapped behind the node user namespace gate.
Yeah, makes sense. Okay.
So I guess from a timeline perspective, or just like a reviewer perspective, Dawn and I had volunteered to shepherd this through the process, but I had wanted to get an ACK from probably you, Drew, on the CRI changes if possible. But I'm just curious if there are any major concerns with what was discussed here, or if not, we'd like to kind of start proceeding on the implementation side.
I would like to read the proposal a little bit. I haven't been following.
Yeah, that's completely fair. I'm just trying to make sure who else wants to be like participating in the process here.
I'll take a look as well.
Thanks,
Tim.
Has Jess looked at this?
We can ping her on it for sure. Yeah.
Okay.
Yeah.
So maybe as a follow-on then, like we allow folks this week to give some review and discussion, and then see if there's any feedback we need to discuss for next week.
Yeah, that sounds good. I'm sure like there'll be a lot of thoughts. So yeah, it makes sense.
I joined a little late, so I apologize if this was already discussed, but have you considered tying the user namespace mapping to the service account as a way of kind of persisting those across volume accesses?
I haven't given thought to that. Probably defer to Derek. Derek, if you have any thoughts, top of your head.
Not off the top of my head right now. So Tim, I need a moment to reflect on that. I guess what's captured here is what we've discussed, meeting our needs on the Red Hat side, I guess. So if there's something else that you think is missing, I think we'd love to roll it in.
Yeah, I'd be happy to chat about that at a later point. But it's just kind of an idea I've been thinking about as a way of dealing with the kind of the volume user problem.
And just to be clear, this protects the node from containers, but not containers from one another, right? They're all running with the same UID mapping, right?
Yep, correct. Yeah.
Yep.
And was there a reason you weren't considering a separate user namespace per pod?
Yeah, so we want to do that in the future, but I mean, I can go into some details. The problem right now is if there are two pods and both of them have different user namespaces, then we have to chown the layers for them to use the root FS. And when you chown the root, I mean the layers in the root FS, you end up making copies. And we basically need kernel support, like so that we don't end up copying the files again and again just because we chowned the layers.
I see.
So we are kind of waiting for that to mature in the kernel. However, I mean, after we go through this first phase, we can still choose to take the hit of chowning the file if you can afford the disk space and enable like per pod or a per namespace user namespace setting. I think per pod might be too granular. Like per namespace might be a logical next step, and then maybe if we can allow users to drill down further. But I think that might be going too much, putting too much burden on the user. Just enabling it at the namespace level might be better, so just users don't have to change their pod configs or anything, and just works for them. But I guess we can discuss that when we get there.
Well, it shouldn't have to be necessarily per pod. It's just per namespace mapping. So if you're using the same namespace mapping in different pods, you shouldn't have to take that disk penalty.
Right. Yeah. So for a pod, you can, yeah, definitely you'll have to use the same user namespace mapping because you share the other namespaces, and if you'll run into issues if you don't share the user namespace as well. But I thought the question was, why don't we allow a different user namespace per pod?
Yeah.
Actually, we're also trying to like tackle this like in a crawl, walk, run type mindset. So like, at least at Red Hat, we feel like having a cluster-wide node user namespace remapping would significantly improve the security of our clusters today. And, forecasting a little further out is probably something that like, I'm not really comfortable doing until we actually, see that first next incremental step.
So in the future, if we got this pod level support, then the node level would essentially be acting like the default.
So we can have like a different feature gate, and like you can either enable node level, or you can enable like a pod / namespace level user namespaces, and depending on what flag you set, the different user namespaces will be sent down per namespace, or you'll default to the node user namespace.
Yeah, to me, this like is the benefit of protecting the host from the workload is what this is trying to support. I think that secondary benefit, if you do something at the namespace level, and man, these terms are also overloaded, is really if you have like distinct tenants sharing a common node. And I think there's a lot of other things to work through when you talk about separating environments for that's why we kind of deferred that beyond the first phase and just said let's protect the host from the workload.
Is there CRI related changes to get this in, or how is it configured in the runtime?
Yeah, so Mernal showed the CRI API changes proposed. And it lets you discover how the runtime was configured. Like no runtime today allows you to program how it should do the configuration for the exact reasons that Mernal talked about why the kernel isn't ready for it.
So do we see this runtime config query or GET request being opened out to use more flags and fields in the future, or is this just going to be for this one?
One immediate use case that came to mind was like the mismatch between the C group driver. Right now we have to match the kubelet with the runtime, and this could be like fixed. We can expose that here as well.
Yep.
Yeah, that one's a little more complicated. I think Philip has a discussion on that. Just because the kubelet sets up C groups even if the runtime hasn't yet been started. But there are probably others in the fullness of time, though.
Yeah.
So that's a yes. Like SEC comp support, that sort of stuff. We could probably add a few more fields later.
Yep.
I mean, discovering it from the runtime lets you just configure it in one place rather than configuring it multiple places. So yeah, I generally agree. And typically distros are more opinionated on how to configure the runtime. So discovering it there is probably a good step in many cases.
And we see this mostly as a query thing, not a push thing.
At least in this case, yes. I don't know. Curious what the community feels that way.
Yeah, that's the reason I'm asking if there's other patterns we might want to use this API for, to push a requested configuration and then get a response back with a yay, verily I can do that or not type approach, as opposed to the what are you doing approach.
So I think there's like an update runtime config or something, and that it has some networking settings. I'll have to take a look what exactly.
Yes, update runtime config is there.
Yeah.
And that sets the port CIDR to be used.
I guess to time box the conversation, it seems like at first Manal and Vikas and Jan, thank you for walking through this. And then maybe we can move the rest of the discussion onto the PR and then try to get all comments closed or queued up for discussion next week.
Sounds good.
Okay. And then next on the list was online volume resizing.
Hello. Can you guys hear me? This is Hemant. Yeah. So this is a proposal that I've been working with Lynn on about online volume resizing, and it involves a change to kubelet, and that's why I wanted to present this in front of SIG Node. And let me share my screen if that's easier. Right. All right, so you guys can see the proposal. So the main change that we are right now for config maps and secrets and projected volumes, we already have a cache that we maintain in kubelet side, and that cache has TTL, and that cache is like if the user updates the config map and then the volume gets remounted inside the pod, and the mechanism is basically the each time we sync the pod, we ask the volume manager to check the PVC, the config map, and if the config map requires a remount, then we basically remount the volume inside the pod. So for online resizing, we need something similar. Online resizing, if you're not familiar with, is like is a resizing of persistent volumes. That means GCE, PD, EBS, and all the other volume types. And we implemented resizing in 1.8, and we implemented file system resizing in 1.9, and we have it working. The only requirement currently is like for the volume types that have a file system, you have to delete and recreate the pod for the final resizing to be finished, because the resizing is only done when the pod is started, after, like during the mount process. After the mount, but before volume being exposed in the container. So we resize the volume at that point in time. So this online resizing proposal is will be presented. Will have its own feature gate. The resizing itself has a feature gate, and it's alpha feature right now. But we are moving to resizing to beta in this release. But online resizing will remain in alpha, and the proposal is that we'll maintain that PVC cache, and we'll have a TTL similar to config maps that we maintain currently, and a similar mechanism we'll use to tell volume manager that the resize is required, and that will be used for performing the resize while the volume is being mounted in the pod. So there are some bunch of like interface and how it will look like and all the description here. But underlying thing that I wanted your opinion, you guys' opinion, is like if the caching the PVCs will be is okay, and or will it cause a load on the etcd server, and then we'll have this caches probably existing in all the nodes. So like all the nodes where the PVC is mounted and in use. So is there any questions that did anyone have a chance to look at the proposal?
Same on. I did not get a chance to review the proposal too deeply yet. I don't know if the rest of the call has. For the PVC cache, are you caching just the PVCs that are bound to that node, or?
Yeah.
Okay.
Just
similar to the secret cache, then you're saying?
Yeah, similar to secret or config map cache. Yeah.
I mean, I think from a performance standpoint, it'd just be a matter of measuring. I mean, and probably be tied to like average cluster sizes. I guess, you're aware of our cluster sizes. I mean, for what you've seen when you were doing the research here, did you have a major concern, or did that come up?
No, I think the cluster size, I think it shouldn't be a problem, but like we probably have to do some measurement at large, like in the large enough clusters, but we haven't done it like for like how it will behave, like when we have 10,000 PVCs and 5,000 PVCs, how this caching and each node, polling for PVCs, basically polling for PVCs, because not always, but like whenever the TTL expires, will look like.
So I get the sense not everyone has a chance to reflect on this, so maybe we allow some time for folks to reflect, and then I think you had another item you wanted to get on the SIG's attention.
Yeah. So we have welcome comments on this one, and we can do this offline on the PR. Cool. All right. So the next item is the dynamic attached volume limits, and this one we had some discussion with Tim and Saad and Upstream. So the idea is like, if you're not familiar with this, how we have things currently is like in Kubernetes, scheduler hard codes the number of volumes, attachable volumes for GCE and AWS. I think these are maybe Azure. I'm not 100% sure, but GCE and AWS are hard coded right in the scheduler. And if we try to increase for AWS like more than 39 volumes, we try to schedule on a node, then we just don't consider that node for scheduling. There's a max volume predicate that rejects the node. Obviously, this does not scale for other volume types, like, for example, the one that are being introduced, so CSI, or even the entry volume types, like unless the hard code exists in the scheduler, anything is like the workloads keeps getting scheduled, and the scheduler doesn't detect it. Even for existing volume types like AWS or GCE, the limit depends on the node type. Like M5 instance type on AWS has lower limit, and other instance type has higher limit, for example. So this proposal is about like a dynamic attached volume limits. So there are like originally I thought I proposed this, that there's a field we add to node object, node.status attach limits, and there we keep the name of the plugin that we use this name internally as like a full namespace name of the plugin that each plugin defines it, and then how many limits it supports. So this is the change that we proposed, and we have to make a change to CSI, but that's unrelated, for not interesting for this SIG. Then we have to, according to this, we have to make a change in scheduler that it can, right now it statically checks for volume types, and that cannot work because we have to do the dynamic check. So we'll have to load the volume plugin managers. That means the scheduler has to be linked with all the volume plugin managers. It has to load and it has to dynamically check which volume plugin is being used in the pod. So so that's one more change that this PR proposes. And then like third change that we have is we need to find out some limits. Like for CSI, the limits will come from CSI, but for entry volume plugins, I propose that in PKG Cloud Provider, cloud.go, we introduce this additional interface volume limits, and that takes get volume limits in a function that takes a context and node name and returns a map like this. So for example, AWS Cloud Provider will return this map, and that will be, Kubelet has this function called kubelet.initialNode, where we are setting a bunch of stuff from Cloud Provider into node object already. So we use that mechanism to set the limit returned by Cloud Provider as well in the node object. So that's the proposal all about. And so there have been some discussions since then, and Tim Hawkins has proposed that we use the capacity API rather than using the status. The problem with capacity is that node.capacity will work, but there's no pod.capacity, so there's no capacity volume capacity for the pod. So we have pod.containers.resources that we can potentially use, but it's going to be problematic. And second one is like the concerns that were raised by Tim and a bunch of other guys is that we don't want to modify Cloud Provider because Cloud Providers are moving out of tree anyway. So adding a new interface will be problematic. So the problem is like if the limit has to come from somewhere, and not having it in Cloud Provider means the volume plugin itself cannot, like all the volume plugins are initialized on the node. So we initialize EBS plugin on GC node. So we don't know which plugins we should put the limits, for which plugins we should put the limit in the node object, either in capacity or where we put it. So the problem is that we'll have to put limit for all entry volume plugins. And that's like, there's like 12 of them at least, and we don't want to put limit for, like, we don't want to stuff 12 objects into the node, and 12, like a dictionary of 12 elements into the node object that may or may not be used in the code. So there's some discussion on those two lines, and I just want to present this for SIG Node and what people think.
So how often you are going to adjust that the limit? All those limits is once being applied and never change, or you really truly dynamic change those limits? I don't know.
They are invariant on a node for most part. So for same node, they will never change. But for like in the same cluster, if a user has heterogeneous environment and not all nodes are same type, then this limit could be different on each node.
Okay.
How do we enforce the limit on the number of pods? If we just do something very simple.
Oh yeah, the configure, but that's not, yeah. More is the cluster hard-coded configure, but it's the cluster level hard-coded.
Yeah, right now the limits are cluster level. It's not per node, so it's like it becomes a problem like when workloads are scheduled or C5 or M5 instance have in AWS, for example. The pods get stuck forever. They never start, and then then we have to basically to take out that node for scheduling from scheduling.
Yeah, this is okay. So this is more like the Node API work, and I have to read your proposal.
Yeah.
But I think that we should address this problem.
Yeah. So I think if people had a chance to look at it, I would request people to have a look at it. And second thing is that also like the Tim is proposing the capacity using, if we can use capacity rather than using the status node.status. So it's something we have to decide, but this needs to be solved like for 1.11.
Yeah, so I feel like using capacity is like going to be a real pain in the butt, to be honest. Like I get that it's a counted resource and all of that, but I think actually inserting that request into every pod to get that claim is like a complicated set of emission hooks that are probably not worth the time.
I think GPUs are already doing that, so they've already established this pattern.
Yeah, that's
the problem. Sometimes that's the
I guess the difference is like this is trying to control something that's already in use today, whereas GPUs were introduced with this concept already in mind. And so that's kind of where I see like the distinction. Same with like, I think the max pod concept, I think that was David I heard said that, like in theory, we could have done a capacity count on pods and made each pod make a request for one pod. But that got complicated just from the history of the project. So personally, I would steer away from capacity, Amon, and I'm not sure what consensus in this call is, but it feels like it's hard to retrofit into existing customer clusters.
There's also like capacity constraints on pod is like is per container basis, whereas the volume workload is per pod basis. So like that's another concern that I had. Like there's no way to count container, like the resources, there's no field in the pod to say capacity. It's a per container basis. So if we are going to do counting for the pod, then we'll have to pick up the one container and retrofit or just push all the volumes that are being used in the pod in one first container of the pod. That's what Michelle was suggesting often, but it seems ugly. And yeah.
Yeah, I think my concern, or to try to echo what Tim's concern is adding in a new set of fields for every new cluster resource or node resource that we have doesn't seem feasible. There are fields that exist to manage node resources within the node object, and the existing GPU design is already using that, has an established pattern, rather than create a separate new pattern for storage. First try and see if there's any way that we can get alignment with that, rather than just create a new set of fields for every new resource that we have.
Yeah, so I think Kaymon's last comment though around like scope of the resources, what differentiates the GPU scenario, right? Like a container
that might
GPU request, whereas a pod makes
it might point to a larger issue where you have resources that are pod level instead of container level. I know that's been a problem in the past for counting, for example, accounting for empty dir usage off the host machine. Maybe it's worth addressing more holistically.
Also, counting of network interfaces, that also becomes a problem because that has to be counted at port level. And network
that's a use case I don't think is broadly accepted yet. So like, I guess best I've seen is Tim's existing proposal, which was the overhead proposal, but we've kind of deferred from doing the pod level resource bucket to this point.
The alternatives I see are like we do a one-off field that's very specific to volumes versus we try to solve this more holistically and have something that can be reused in the future for other resources.
Yeah, I think if we are planning to add a field that could be reused across other resources, then we have to we have to tackle this problem at a different scale, I should say.
Yeah, so I mean, I've long been tempted the idea that we should have pod level resource requirements, but then at every step of the way, I think told me why that's tricky. And so I don't know if it would actually scope to every resource available today or not, or it's just a different bucket.
Yeah, it might be a different set of resources that are specifically pod level. This could be a forcing function to help design that interface because it's concrete, it exists, it's a real pod level limit.
Yeah, but I think I don't know who's speaking. Sorry, but he's saying that like we don't know if such a field will be used by other resources because.
Yeah, it's like a chicken and egg in both directions, right? Like it just because I'm saying it's not clear that it would necessarily be used for CPU and memory or even ephemeral storage, right? Like we've done ephemeral storage without this field. So there'd have to be, it would have to be just like some other general purpose counted resource that's not associated with the container lifetime. And I don't know if we're running out of other scenarios for that.
I think GPUs would probably be the best alignment there, but they've already set off on a different course. It might still be worth pulling them in to try and see if there's any way we could get a cohesive design rather than every single resource doing its own thing.
Can you elaborate why you think GPUs are different?
Oh no, I think they're very similar to storage.
I guess can you elaborate why they're similar?
In both cases, you have a device that is going to have a set of node level attributes or limits or capacity essentially. There are a certain number of GPUs that are available on a given node. There are going to be a certain number of volumes that can be attached to a given node. Those two seem like a very, very similar pattern.
Except one today is scoped to a container, right? GPUs are requested on a per container basis, not a pod basis. So if I have a pod that has two containers and each container requests a GPU, then they get distinct GPUs. So like GPUs aren't shared across containers in the pod.
That's true. That's a good point. Yeah, I don't know. I can't think of any other resource that would be pod level other than storage dense.
As I said earlier, network resources are there, which are the same as portable, but as Derek said, that's not an acceptable use case.
Yeah, I guess anywhere where you have namespaces that are shared across multiple containers, you could potentially have limits that apply across multiple containers. So networking theoretically could have limits.
I think that I mean, to me, it looks like there was some consensus around the node.status, and yeah, I see what Tim is saying, but it seems like there's a landmine there that we need to trip and I don't know, like what this or fix. So
yeah, ultimately, I'm not. I don't feel super strongly one way or another. I think if the consensus from SIG Node is that having a new set of fields for this is okay. I'm okay with that. I think my bigger concern is about how that value is going to be populated, and that we can discuss on the PR.
Yeah, I mean, you should avoid, like, generally speaking, if you're going to add a kubelet parameter, you should avoid adding a flag and try to use the v1 beta 1 config API, which, like, if you only need this in v1.11 up, then that's what you should do. If you need to backport it to older versions, we can talk about that offline.
I don't think we'll need to backport this to older version. So
yeah, in that case, I would recommend just adding it to that API. And people who are provisioning configuration files, instead of using flags, can do that. All the flags that point to that file are deprecated, and they're going to be removed soon, so we don't want to add more.
what was that? The flags about? Sorry.
Yeah, so the kubelet is moving to the component config model, where configuration is specified in a version format via a config file. So, like, it's best to, if you can avoid adding flags to the kubelet and instead use that config file, that's preferred.
Okay. Yeah. Okay. That was not. Yeah. The CLI argument is not final. There's still back and forth discussion going on that. So yeah. Okay. I'll keep in mind. We'll keep in mind. Cool.
Sure thing. Thank you.
So is it fair to summarize this as consensus on SIG Node is adding new field for these values on node status is an okay path forward?
I don't really have an opinion on status.
I'm not strong opinion on those things, but let's carry discussing. I think that some people haven't read your proposal yet, so let's carry this one.
Okay.
I would say, Saad, my consensus is that this is different than GPUs and CPU and memory, and so
I agree.
I think that was a clarifying discussion, and then really I feel like the value is invariant to the life of a node, then like the write rate of that field is not too concerning. So then it becomes more of like a to me, this feels like something that complicates scheduling, and the node is kind of just an information delivery vehicle. But like, it's really the scheduler who has to do more complicated work.
Yep.
Just generally speaking, do we have like a policy on not adding things to the node object? Because like, haven't there been scaling issues like with the growth of that object?
The one that stands to mind was when we tried to record the images that were actually running on the node.
There's many things. Image is just one thing, and there's the label. You can add tons of label, tons of the annotation. So basically, big node object costs because the way how the etcd implement, and then it causes some of the scalability problem. And also another reason is just because we keep update. We send the heartbeat and frankly, and so update that large object every 10 seconds. That's cost this problem.
Yeah, I think etcd has to write the entire object on every change. That's my understanding.
So that's why I didn't brought this up, because we still need to update this node object until we solve this problem fundamentally. Even we don't add this whatever to introduce this one, there's some other thing, even already existing.
Yeah.
Okay. There's no other comments on this proposal. I guess we can move on the agenda. So the last item in the agenda was one that I'm sure that gets everyone super excited, which was trying to write down what our charter was. David, I appreciate the dance. So I've been working with Dawn in the background, and I guess I will share my screen and let people view and comment. Where basically there's from the steering committee, there's been a kind of reference template charter that basically each SIG has been encouraged to respond and adjust to, and just kind of enumerate the roles within a SIG and basically the process by which the SIG functions. So I have adapted that template and tried to apply it to SIG Node, and I appreciate Dawn with some of her initial comments and feedback, because that's feedback that needs to go back to the steering committee, because in some of these cases we want it to be consistent across the project. And so what I wanted to do was ask everyone who is a member of SIG Node and has been working in the space to read the document and maybe understand the roles that are enumerated and the powers that come with them, and ask any clarifying questions that could be made to adjust. Generally, I'll just kind of quickly go through this. So like SIGs historically just had like leads and members, I guess. And there was a recent adjustment to kind of split the lead role into two actors, a chair, and then potentially a set of technical leads. At least in SIG Node, I think when the paperwork was flipped, it was still me and Dawn that were the historical leads, and then now we're still the present chairs. And chairs basically, you can see the process here, but run the operations of the SIG and ensure that like stuff is happening. But it didn't necessarily need to be doing like the technical aspects of the project. So there's an opportunity for folks to be a technical lead, but not necessarily be a SIG chair. And so the technical lead role would be new to the SIG. And just from convention, from what the steering committee had pushed out, was that like the initial list of technical leads would be seated by existing chairs. So if folks are interested in being a technical lead of SIG Node, I think Dawn or myself would be interested in knowing that. So please reach out to us. But basically a technical lead should be someone who's well seasoned in the project, has a lot of breadth of experience, and they have some unique powers for subjects that we've been discussing over the last couple months, especially with respect to sub-projects. So I think there's been discussions about how we can get a new sub-project sponsored by SIG Node, whereas previously there was the incubator process in the project, and that's kind of been deprecated, and now there's a per SIG sub-project process. So the major, I guess, power that I would see that a technical lead would have in the project is that they can sponsor the establishment of new sub-projects and then potentially decommission existing sub-projects. Now, this is a clarifying item. We need to kind of work across the project on like what the process would be to decommission. Like in theory, it would be different if the project was completely unmaintained and not healthy, and it's possible we actually have some sub-projects in SIG Node that are like that, versus a project that is healthy, actively maintained, and has users. So kind of have to work through the edge cases on that. And then the other major thing would be that technical leads within the SIG could sponsor the formation of a new working group. And so like if you wanted to spin up a new working group or decommission it, like typically working groups are supposed to stay on SIG. So I guess in theory, a technical lead from each SIG would agree to sponsor the group. Otherwise, folks can read through the details. I think there's proposed numbers for the number of technical leads that one might have in the SIG. And then there's an additional role for sub-project owners. I don't know how much people have been following the governance updates in the project, but basically a sub-project owner would be someone listed in the top level owners file of the project, and they basically shepherd management of that individual sub-project. And so like today our supported sub-projects in SIG Node would be things like the kubelet itself or cryo, CRI containerd when it had been in the tree, node feature discovery, node problem detector. There's probably a couple I'm missing off the top of my head. And in theory, you can be a sub-project owner without necessarily being a technical lead in the SIG. So like you could drive the development of your component, but not necessarily sponsor the formation and development of new components. So that's kind of the laddering system that's been proposed in the community. And folks can look through and see what the responsibilities would be. And then, like, generally speaking, just trying to codify like best practices within the SIG. I think we've done some of this today, actually, which is good, about talking about how we like propose and make changes. So I think generally there's been a push to try to make broad changes more visible across the community. And so like the KEP process would be a way to do that. So I think what Mernal and Amont presented today is emblematic of what we would look to see, but generally speaking, like, at least make sure everyone is aware of a change and at least have a discussion about a proposed change at that level in at least one SIG node meeting. And then we can talk through some details, but I know we have 1 minute left, but if folks could give their feedback on the charter, both generally as charters exist in the project or as the charter applies to SIG node, I think it'd be appreciated. And then just for reference, like the steering committee is going to, in our next meeting, look at a cross-section of charters that have been authored across the various SIGs and try to see if there's any patterns or commonalities on what we want to improve. But hopefully there's nothing too contentious or crazy here, but feedback is very much appreciated. Any questions or comments? Okay, I know this isn't the most exciting topic, but so the next step on this would basically, I think there's a member of the steering committee that'll be paired up to review each SIG's charter and work it through the approval process. So anyway, I think that fills our time. I don't know, Dawn, if you have any parting words for the SIG or things we want to bring up that weren't raised.
No, thank you.
Okay. All right. Well, thank you very much, everyone, and I'll try to get the meeting recordings uploaded. See y'all next week.
Thanks, Derek.
Thanks.
Bye, guys.
Thanks, everyone.